So we do have 5 objectives for today, but 2 of them are holdovers from last time, and I really think that we're good luck. I really think that we're quite set with that. We do want to describe and give examples of induced transmutations, and we want to continue to construct and complete nuclear equations. We do have, just in time for our next vocab quiz, a couple of defined objectives, or one defined objective. We want to define the term unified atomic mass unit. And then we have 2 objectives that involve our only equation in topic 7 of the data booklet. We want to apply the Einstein mass-energy equivalence relationship, and then we want to, some more, define the concepts of mass defect, binding energy, and binding energy per nucleon. Out of all of these definitions, this one's pretty ugly, those ones aren't too bad. Before we spend a few more minutes on induced transmutations, though, let's just figure out what else we need to do about the medical isotope presentations. I believe that we have already decided that you will share them with me, like there'll be Google presentations and you'll share them with me. That will work fine. I think I have the scoring rubric up here for us, so I gave this to you. So let's just go through this, and if you have clarifying questions, now's your chance to ask them. So the first thing, which is 12 points, the biggest part of the score, is the medical role of your isotope, and then an explanation of why that isotope is suited for that role. So to get all 12 points, you need to clearly explain the medical use of your isotope. You need to demonstrate a clear understanding of why the isotope is used for that. And in parentheses, I have especially the element, right? So I am concerned about not just the nuclear properties, but also why that element. What is it? Well, let me not say more about that. And what else? So that's what I have on that. And then for 2 points, you need to clearly state whether your medical isotope is used for diagnostic purposes or for treatment purposes. Oh, I did have one other tiny thing up here. If your isotope has multiple uses, I wouldn't try to thoroughly explain each one, right? It's just going to take way too long. So if you do find that yours has 2 or 3 or 4 uses, feel free to mention them all if you want, but hone in on one of them. Otherwise, you're not going to hit the timeline. All right, next, 5 points. You're identifying the half-life, and you're explaining why that half-life works for the medical use. For 6 points, you have the type of radioactive decay. So you're going to indicate which of our types of decay it does. You're going to identify how much energy is released when it does that decay. And you're going to clearly explain why that type of decay works for the medical use. 2 points, you're going to cite all of the information that you're including in your slides. Citing is different than just having references. So I expect to see at where you're displaying the information, like I need to see, be able to match that up with your references later on. For 2 points, I'm looking for you to identify how your medical isotope is manufactured. I'm not looking for a ton of information here, right? It should take somewhere between 5 and 30 seconds for you to do that. Probably closer to the 5-second side than the 30-second side. And then finally, for time, right? These should not be long. This is only 1 point, right? But it should be somewhere between like 2 minutes and a little more than 3 minutes, right? 115 seconds is a little less than 2 minutes. 215 seconds is not quite. Or no, actually it's a little more than 3 minutes, right? All right, questions? Yeah, Elizabeth.
For the amount of energy released,
Yes.
are we finding that in joules? Or
Preferably not. Preferably in kilo electron volts, mega electron volts, probably not giga electron volts. Joules is okay, but I think you're way more likely to find it in terms of kilo or mega electron volts. David?
Since you want to be able to match up the references and information,
Yes.
you want us to be constantly referencing throughout the PowerPoint.
I don't think that's necessary, but I mean, how do you cite stuff for like a history paper? Like, do you use like author and year, and then you match it up at the end with like citations or something?
Like, we do like footnotes and then we put it along.
You can, no, I don't want that because then that's going to eat up a lot of the area of your slide. I don't know, maybe you could do like a little number 1, and then and then you have your first citation at the end, and number 1, like any place that I see a number 1, I would know you got for that. Yeah, something like that. Something like that I think would work well. Lauren?
If explaining why we use the isotope for the medical use,
Yes.
that's like the nuclear properties, like the decay and the half-life.
No, but fine. So let's say yours does alpha decay. There are hundreds of things that do alpha decay. Why your one isotope for that use? Nick?
For references, can you
Yes.
just at the end of the slide, in the references slide, just put like the website we got it from, or do we have to like go specific?
I really hope that every piece of information is not coming from the same source.
Yeah, I know, but I mean, like, do we need to have a certain way of citing, or can we just?
Oh,
base
I
the
don't
website?
care. I mean, I could tell you, yeah, use APA, but I wouldn't even know if you were using APA or not. No, I don't care. I want to be, if I doubt something, I want to be able to go to the thing on your last slide and see what you saw. Other questions? All right. All right, so for our last little piece of artificial transmutations, I'd like you to come up with your own example of an induced transmutation. And I don't want to give a ton of time for that. Maybe like 90 seconds should be sufficient. Then, in your, do we actually have any? We don't have any foursomes today. We have threesomes and twosomes. In your threesomes and twosomes, I'd like you to share, and I'd like you to try and be a jerk and say, no, it's bad. Here's why it's bad. Right? So I want you to see if you can like rip holes in the transmutations that your twosome or threesome members came up with. The thing that's inducing the transmutation does need to be really small. Right? So I shouldn't see anything bigger than an alpha particle as being shot at your nucleus that's then going to have a decay induced on it, right? So nothing bigger than an alpha particle along with whatever your other starting nucleus is. All right, any other questions that need to be answered in order for you to come up with your own example of an induced transmutation? Great, so let's just take, I'm hoping it really will only take 90 seconds, and then when you finish, right, check if the rest of your group has finished.